Okay, good afternoon and welcome to the second session of this afternoon. So we have with us Professor Shamlal. Professor Shamlal is faculty in Department of E&C Engineering, NITK. So I just give you a brief bio of him. So he received his MTech degree in Electronics Communication Engineering from NIT Kurukshetra in 2007, PhD degree in Image Processing from Birla Institute of Technology, Mesra, Ranchi in 2013, and he has been working as Associate Professor in the Department of E&C Engineering, and he joined this department probably in 2013. So he has more than 100 publications in the area of image processing, deep learning, applications to biomedical as well as remote sensing images. His research interests are in the area of digital image processing, satellite remote sensing, medical image processing. So I welcome Shamlal. So over to Shamlal.
Okay, I hope I'm audible, right? So, and I hope you have got a lot more knowledge related to medical image data analysis for maybe one-dimensional or two-dimensional by Professor. So I will be taking you in the current era, which is called, deep learning era. So in deep learning era, most important the deep learning model which going to be used for medical diagnostics or subtype of cancer grading and so on. So I'll be discussing that, but before that, as try to teach you some fundamental concept, right? So starting from the very basics and take you to the advanced level, and third day I will be demonstrating one as a laboratory experiment. More specifically, the work which we have carried out at NITK Surathkal in the area of called digital histopathology. So that's the area where we have contributed immensely in globally as well. So that will be the core application, specifically for cancer detection and grading as a task. So these are my outlines, which will be little very brief introduction. Then neural networks, building of perceptron model as a concepts, and then deep learning models. So in deep learning model, today class will be focused on just two-dimensional convolution neural networks, right? And tomorrow we'll see as a more specific and like how cancer grading will be done. And before moving to a deep learning field, so there are some prerequisites. So prerequisites like you have first require domain technical knowledge, and the second is the software and hardware skills. In a domain technical knowledge, start from the linear algebra, probabilities, statistics, fundamental of image processing, fundamental of computer vision, and a strong foundation on artificial neural networks. So if you have a strong foundation on artificial neural networks, then understanding of a deep learning concept and the models will be much easier, because the workflow will be more or less same, only slight change will be in the form of feature extraction, that's all. And then the other related subjects, this is more specifically like domain, like domain knowledge or domain expertise. For example, this GIAN program is mainly focused on the medical data, image analysis and so on. So the knowledge of medical signal processing, medical image processing is essential, right? So that should be the sum as a domain expertise. But why this domain knowledge is necessary? Because from the domain knowledge you will get a good problem statement. So who will give you medical field good problem statement? You have to visit the hospital, doctors. So doctors who are working in the hospital in different departments, they can only give you a very good problem statement. Once problem statement is there, next task could be the data. So data again will be provided by the hospital, right? The specialists like maybe oncologists or maybe this ophthalmologist or skin department and so on, right? So once you have a problem in your hand, which could be, in your hand, the next step would be to find out the solution of the problem which was formulated by the expert, domain expert doctor, right? And then to solve the problem, you require the software skills. As you know, we are in the era of open source. We are in the era of digital, right? So in an open source era, the language, the Python is one such important language which is used, right, worldwide in almost all industry, academia and so on. So Python is one, I would say is the third, frequently used language for the in industry as well as academia, in lab and so on. So this Python coding has to be learned. If you're not aware of that, not knowing, then there are some other important libraries, NumPy, SciPy, Panda library. Panda library again very important because your data will not be always image. Your data may be a text data or maybe your .csv file, right? For example, if you have 1D sensor, right? Biomedical sensors, for example, your ECG, EEG, EMG, right? All the things that give you always a one-dimensional signal. And normally the data which a doctor will captures will be in the form of .csv file, right? So if you want to, right, load the data or want to analyze, process all the things, the data will be 1D format, right? CSV file, right? So those data you cannot read straightforward like other tools. So Panda library is very essential in the case of one-dimensional data, right? Like ECG signal is once or EEG, right? So that's this as a working knowledge is very important. Then OpenCV is not related to a medical data because medical data have their own format. It may be a DICOM format or maybe other. But if there are some other medical data, for example, histopathology, right? So histopathology images will be in the form of like JPG, right? So for the histopathology, if you want to see OpenCV library, you should be aware of that, how you can read, write, do some sort of pre-processing and so on, right? Then third, the important as a prerequisite will be in the field called scikit library. So scikit library is extensively used by the machine learning that engineers in the last, I would say that, started from the 60s. When this library was developed, the intention was put everything in the one package, right? So this library that's called scikit library having four important as a role. First, this library give you the lot more ready-made data set, right? So ready data set already there in the API only. You can just that import the data and you can do some sort of your learning experimentation. But those data are only for the laboratory experimentations, not for the clinical or the research kind of applications, right? Then second is this library also give you facility or they support you guys to do some sort of data pre-processing, right? See, as I might be aware of that, in a machine learning era, you cannot give a real sensor data exactly to the machine learning algorithms. You need to do some sort of data pre-processing. And in data pre-processing, you have to do one such important called feature normalization. So feature normalization is must in a machine learning field. So if you want to do feature normalization, right? So this library will help you to do feature normalizations. So there are three kind of feature normalizations. That's called feature normalizations by mean and standard deviations. Second is feature normalizations by mean and max. And third is approach would be feature normalization by max approach, right? So basically this your min, max and max all mainly suitable for the image data task applications, right? Apart from this like feature normalizations, right? If you get the data from any hospital, so doctor what will the data? Data will say that this is cancerous tissue or cancerous image, non-cancerous image. So they'll create a data, cancerous, non-cancerous, right? But algorithm doesn't understand what is cancerous or what non-cancerous. Algorithm understand only, what are the algorithm understand? Numbers, right? 0 and 1. So if it's a cancerous, right, you have to convert as a 1, right? If non-cancerous, convert as a 0, right? So a moment you convert like cancer, non-cancerous into a 0 and 1, these are nothing, these are the labeled ground truth, okay? So these things, right, you can do it by using the again scikit library, which the syntax or this function will be used called label encoder. So label encoder will help you to do that converting like the string like yes or no or cancerous, non-cancerous, benign, malignant into a 1 and 0 format, right? So this is one pre-processing part. Third most important thing is the library also give you ready-made traditional machine learning algorithms, right? When I say traditional machine learning algorithms, that means support vector machine, random forest, decision tree, KNN, multi-ray perceptron, linear regression, and so on, right? So all the things that's called supervised, right? And like your k-mean clustering unsupervised, right? All the things are also available in the scikit library, right? So you can use those that machine learning algorithms for solving some problem. But my advice would be here, do not use any library unless you have a thorough understanding about the particular machine learning algorithms. First, you need to go back, read a detailed theory. If possible, try to implement from scratch by using the Python. And once you are able to comfort that, then later on use the library. Because ultimately you are going to use library because it's professional way developed fast also, right? So you have to use. But before that, try to implement your side only. Then a fourth important of the scikit library is to quantify machine learning and deep learning algorithm, right? Because as you are a student or faculty or research scholar, right? Your role will be always, doing your project work, right? So once you do a project work, so you will be simulating various algorithms, models, right? So once you do various algorithms like algorithm 1 or model 1, 2, 3, 4, 5. So you need to do the state of comparison, right? State of art comparison. To how do the comparisons? So for doing the comparison of different algorithms or the models, you need to compute various quality matrices, right? In the machine learning and deep learning, right, various quality matrices are like precision, recall, F1 score, accuracy, kappa coefficient, intersection of union, Jaccard index, and so on, right? All those matrix, quality matrices, you can easily compute by using this scikit library also. But nowadays, even this deep learning library is powerful. You can also do many quality matrix analysis using the deep learning library also, right? But before that, no, everyone using this scikit library for quantifying machine learning and deep learning algorithms also, right? Next is deep learning library. So in deep learning library, again very important, if you want to building a advanced AI model, so to develop or to code advanced AI model, you need a deep learning framework, right? So either you can use TensorFlow framework, library package you can use, or you can use PyTorch, framework, right? Depend on your own capability, in which framework you are more comfortable. If you are happy with the Keras framework, you can implement Keras framework, right? Using TensorFlow. If you are happy, right, PyTorch, you can go for PyTorch, right? So in TensorFlow, this was introduced in 2015 by Google R&D, right? Whereas the PyTorch was introduced in 2015 again by the Facebook R&D. Both are powerful, deep learning framework packages. But PyTorch, if you are passionate about doing too much coding, a lot more things, you can do PyTorch. If you are lazy guys, right, don't worry. You can use Keras Primokal. So where you do not require do too much coding, right? So most of the functionality is already available. Just you have to import, but you know how to create a good architecture, good feature extraction. That will help you even the TensorFlow also. But only publishing paper is not ultimate objective, right? Whatever project you do, at least make as a product, right? So once you want to make as a product, either you have to be a software product. If it is a software product, you have to make as a mobile based app or web based app, so that it reaches to the users. Like for example, medical software has to be used by the doctors. How doctors will use? If you give ready-made, right, either web based app or the mobile based app, then only they can use. Otherwise, no use of whatever the work you publish it, right? And then next would be whatever work you would have to do. If you have to go for hardware realizations, real time work. So some of the things, if you want to build in a real time or hardware based, so you can do like edge devices, right? Edge devices, embedded system, you want to deploy AI models. For that you can use Raspberry Pi, you can use NVIDIA Jetson Nano boards, or you can use FPGA boards. But FPGA, that's called Xilinx Ultra Skill, that's cost around roughly 5 lakhs, right? That high end, right? If you buy, you can do there. Or these two are edge devices like Raspberry Pi and NVIDIA Jetson Nano board for simple task you can do, right? That's for real time object detection and so on, right? So this is just about the prerequisite, right, of deep learning, right? Now let's move on this neural network, right? So in neural networks, so journey start from the ANN, right, for the deployable. Whatever you see, this is for use for the developing some solutions, right, in a medical field and other field as well, right? So start from the ANN, right, then deep neural network, then the CNN, then RNN, then generative adversarial networks, then graph neural networks, then Bayesian transformer, transformer based model, then liquid neural networks, which was introduced in 2020, and this CAN network is 2024. So if you want to make your career as an expert in the domain, you have to be up to date right now, and up to date in the sense that you have to read latest development in the field of neural network and try to incorporate this neural network with the existing available classification model or other models. So if you do something, your research would be valuable research, right? Otherwise you can do, but how it is going to be useful as a product form, right? So as a story, so that neural network is started 1944, right? First work was like neuron models by Maklow and Pitts. So Maklow and Pitts, they have given the concept called neuron, right? And they build a simple neuron for arithmetic and logic operations, right? So this, except this part, if you remove this bias, this everything we call as a neuron. Neuron in the sense that when Maklow and Pitts, what they did, they use the input as a logic input, and the bias, the weights should be equal, and then fixed threshold values, right? So the formula, what the concept use, that equal weights, right, and the weights W1 and W2 should be greater than threshold, right? That's what the concept used. But that neuron was not having the learning capability, right? So in later on 1954, that the concept that's called learning rule introduced by Rosen and Blatt. So Rosen and Blatt, they introduced the concept of learning perceptron. That's called perceptron model. So in perceptron model, they have given called learning rules. Learning rules is nothing like this here, right? So WT plus 1 is a new weight equal to WT minus neta del loss y hat comma y divided by del W. This is called gradient of the loss, right? We'll come to more detail later on. And this neta is a learning rate parameter, which is a constant between 0 to 1, right? This is initial bits, right? So here if you see that these are the inputs. These inputs are nothing, these are the features, handcrafted features. Like when you want to go for, do your, blood sugar test, right? So there are various parameters right now, like various hemoglobin, blood pressure and so on. Various features will be extracted from your blood, right? And those features given as an input for, detecting whether you have, sugar or not, right now, sugar levels, right? So these are the features, input features, x1, x2, x3, and these features are multiplied with the W1, x1 W1, x2 W2, and x W1, right? And just forget this part, right? If this is not there, as a perceptron, a simple neuron, right? And then sum it, and then after there is activations, and then output called Y1, right? This is one neuron, right? And as I told you, the Rosenblatt in 1954, he has one thing, learning rules, right? And second thing, what he has done, he added one more input called bias, right? So bias is used here, right? So if you see this as a perceptron, right, is y1 hat equal to f b plus sum of xi wi, right? So here xi is your input, which is again it could column vectors, right? And wi are the bits. You can do just scalar product, right? Just do the product of this right now. And then x1 wi, sum it, and then b bias. Bias is used, the purpose of the bias is to adjust output of a neuron. Simple concept, right? If we are using bias, if we give the power to the neuron to adjust the output of a neuron, right? And the bias value, it may be positive, it may be negative, or it may be any random values, right now. Okay, it may be 0 also, right? Any values what you can there. So here you see that once you get it, this is input, right? Then this is a function called activations, right? So this play a very significant role, right? So these activations are two types, right? But when Rosenblatt used, they use called thresholding active, let's call it step activations. But normally the activations we say either linear activations or non-linear activations, right? So if you say linear activation, fz equal to z. This is called linear activation, where z equal to nothing, wx plus b. Okay, simple. And if it is non-linear, right? But question is here whether we have to use linear or non-linear, right? Let's assume that if you are using linear activation functions, that neuron here, right? So if we are using linear activation function, network as a whole can solve only a linear problems, right? But whatever the problem we have surrounding us, any task you see, is speech recognition, cancer grading, cancer detections, right? Satellite data analysis, right? All the tasks is a very complex task right now. So this part, right? Instead of using the linear activations, you have to use a non-linear activations. So non-linear activations that give the power to neuron or the say for network to solve a complex problem, right? So there are various type of non-linear activation functions, right? Which could be a sigmoid activation, tan-H activation, and the Lirlu activation and so on, right? So a lot of activation functions are there. So in a simple word, what you do, this nothing what you're doing, it's a normalizing, right? Whatever the input is there, this plus this, use the sigma, any activations, you will get the different values, right? So this value basically is nothing the output of a neuron. So mathematically, let's assume that if you are using here sigmoid activation, right? And sigmoid activation defined as, right? So let's assume that you have z equal to plus 10 and z equal to minus 10. So if z equal to 10, what are the values? Sigma plus 10, what do you get? And sigma minus 10, what value will get? This value close to 1, right? If you compute that, 1 by 1 plus e ki power plus 10, right? So higher values, and this 1 by e ki power 10, this becomes smaller, 1 by 1 plus is smaller. So overall values come to 0.9, maybe 8, something like that, okay? If you calculate that, right? And this value, what you come to? 0. Maybe 0.1, right? Okay? Whatever the input, right here. And if you're increasing the value, let's z equal to 100, right? Z equal to 100 plus 100 minus 100, what will be? Right? This value will be more closer to 1, right? You may get 0.99, right? Something like this. This value will be close to zeros again further, right? So idea is that here this normalizes your input data, okay? Clear? And this output of the neuron, once we go for multi-layer perceptron, right, it will be used as a input to the next layer, right? So now here as a learning rules, principles, right? So here W nothing, these are the bits I am talking about, right? WT plus 1, or you can write WI plus 1, WI also, and del loss y comma y hat divided by del W. So W is a bits, right? So this is called gradient, right? So moving ahead, yeah. So this is there. One more important point of this sigmoid activation function is that derivative, right? So derivative of the sigmoid activation function, you can also easily calculate sigma dash x equal to sigma x 1 minus sigma x, right? So the good thing about the sigmoid activation function is that you can compute the derivative of the functions without need of any specialized tool, right? So gradient derivative is computed from the function itself, and sigma x already computed, right? That's good thing about this. And if you plot graphically, so here you see that the red curve represents the sigmoid activation function, right? And you see that right now. And the values of the sigmoid activation, as I told you, between 0 to 1 range, right? So three important properties keep in mind in any activation function. The non-linear, right? Function should be, activation should be non-linear, should be continuously differentiable, and should be a fixed range. Three key important properties keep in mind. And here, but one problem is that sigmoid activation functions called always, if you look at the output, right? Output is between 0 to 1, right? That is not always correct, because sometimes that negative values also make a significant, right? So that the values, instead of always the output between 0 to 1, what can we do? We can use better activation function which is called tan h activation, and mathematically fx equal to tan h 1 minus e to the power minus 2x divided by 1 plus e to the power minus 2x, right? Now very simple, need not to do by heart, remember this expression, right? From this, what do you do? First always remember e to the power minus 2z, right? Here plus sign, do the reverse here, that's all. So you can write the tan h expression very easily without doing by hearting right now. Just remember the sigmoid activation, that's all, right? And also derivative you can easily compute, which is nothing, f dash z equal to 1 minus fx whole square, right? And the range of this tan h activation is from minus 1 to plus 1, right? Okay? So in the sense that here the value will be always not a 0. If you are giving the some negative value, the value will be close to minus 1, right? So you have bigger bandwidth, right? Instead of 0 to 1 feature values, now this node, the feature values will be minus 1 to plus 1, right? So your bandwidth has been increased, right? And you can see that this derivative, so, and the function, if you see here, like this will be increasing, so that's called, function is a monotonic, but if you see the derivative will be always a non-monotonic, right? Okay, so this is the derivative part here. So blue curve indicate the derivative of the tan h activations, where this call your tan h function, red curve here, right? So this is a non-monotonic functions, right? And these are properties which I already told you right now. Then these two functions has one major problem called vanishing gradient, right? Vanishing gradient means here, if you just closely observe, what you can see? This is a function, right? A time may happen here after some time. The function, when the input is increasing, right? The function may have, stop increasing the value. That's called saturate. When the function gets saturate, right? If you calculate the gradient nothing slope, right? The slope, if you calculate, that will be 0. Once completely saturate, the slope will be 0. Once slope is 0, then there will be no learning will happen. Why learning will not happen? Because ultimately we need to get the gradient part, right? Okay? So this gradient part, I'll come back later on, more detail later on, but this where, while computing that, play significant the role of the gradient of the function itself, right? Okay? So once gradient become here 0, right, then the network is stop completely learning, right? When gradient becomes smaller, the learning will become slow here, right? So here that's called vanishing gradient problem. When 0, then learning will stop completely. That's called vanishing gradient problem, right? I mean gradient becomes 0. That's why you call it vanishing gradient, right? But if you see the tan H case, the vanishing gradient occur later, right? So you see that there's better curve here. So the tan H give you even the more better range output -1 to 1, and also the vanishing gradient will take place in the latter stage as compared to the your sigmoid activation function, right? So what is the solution? Because both are having the same problem, vanishing gradient problem, right? So solution is we need to use the function which overcome the limitation of vanishing gradient problem, right? So vanishing gradient problem, the problem can be overcome by using the linear activation functions. So linear activation function was introduced in 2010, right? That's called ReLU activation, rectified linear unit, and this was extensively used started using after 2012 when the Alexander model was introduced. That before that not much use, but Alexander model after the introductions, right, that everyone started, boom started deep learning era, right? So everyone started using the ReLU activation function. So it's a most common use activation function in the deep learning field. Mathematically this, and right, the function f z 0 just less than 0 and z greater than 0 here, right? Derivative f dash z equal to 0, z less than 0 and 1 z greater than 0. So overall it's a non-linear activation function. We have to always look overall, right? Whether the function is linear or non-linear, right? But if you see that it's a non-differentiable at 0, but everywhere you can differentiate that. So here if you see the any point, if you calculate the gradient, right, slope, here there is no point of vanishing problem, right? Okay? But this function also have, this somehow is very good activation, right? Apart from the previous activation like sigmoid and tan H. Apart from this, you also know very other activation function. What sine and cosines, these are also activation functions, right? They are called soft sine activations, right, also used, okay, in the multi-layer perceptron as well. So you can use other also try. So lot of the variant of this ReLU activation functions also there. That's called leaky ReLU, P ReLU, SeLU, ELU, and so on, right? When you do research, you have to explore the advanced activation functions, right? And JLU also is there, that function, there are a lot of functions are there. And this function ranges between 0 to infinity. Right, yes boss.
You talked about the function being having vanishing gradient only in one direction but not the other. Could you please explain that? That is, for negative...
This case?
In that case also for negative values, again, you don't have the gradient vanishes.
Wherever gets saturated, whether positive or negative, right, with that saturation will happen. Vanishing gradient happen here also and here also. Wherever saturate come, where the value gets saturated, start the value changing, there only the vanishing gradient problem will happen.
Same with the ReLU.
Yes. No, see, here there is no saturation will happen because it's increasing values. So here that such situation won't happen. That's why it overcome the limitation of the vanishing gradient problem, right? Whatever was there in previous cases. Keep on increasing. Value goes to infinity, right? But still the problem of this also have some limitation because it always negative give you the 0. So that's why that's called leaky ReLU. In leaky ReLU what will happen? There will be some alpha will be placed which have the minus some values. Let's say 0.1 or 0.2 something like that values. So that the negative value should not be 0. Right? That's called leaky ReLU, right? And so on other activations are there. But this pretty okay activations in as far as deep learning field is concerned, right? So
It's just crazy about thinking like this. I started thinking diode as your whatever this unit activation function.
yes. So now whatever you have just learned a simple perceptron model. Perceptron model is very powerful, right? I mean you can learn, you can do many things right now. So what this perceptron models, right? And this is a learning rule work for this perceptron model. You can do 3 tasks, right? Regression task, binary classification task, and you can build even the multi-class classification task, right? Now, example I give you a lot more real example tomorrow. I'll just talk on the concept today. But when you are going to design or build the model, right? The perceptron model, these are the regression tasks. So regression task is very simple concept. You are going to, your model will predict always a real value quantity. Real value quantity mean in the sense that always is some number, right? Number will be like 1, 2, 3 or maybe thousands, lakhs, depend on the task what you're doing, right? Simple example, if you see that we have here human, right? If you want to calculate that age of a person, right, from the facial image. So age of a person, everyone have some number, right? 20, maybe 30 or maybe 40 like that, right? Or 18, 20 like that. So age is a number, right? So age estimation is a regression task. Simple, always you not forget, right? Apart from this, you can think about like any predicting the sales price of house or stock market. Best example. Stock market is nothing your regression task, right? Keep on changing everybody. So have to predict what will the future price, the share price, right? Now price is always values, right? So that's called regression task. I'll give you some medical example tomorrow, right? But in a medical field, right, you can do lot more things. Data fusion, if you remember that, multimodal fusion is one task. Apart from this, right, predicting the brain age. One is the age of a person, brain age, lung age estimation, right, from the CT scan. These are nothing, these are practical example of the regression task, right? But this model will not be enough for that. You have to go for the deep learning models. So here to build any perceptron model, 4 important parameters always keep in mind. That's called one activations. Activation functions always you have to use linear, right? Activations, nonlinear activation inside the network, and loss function, and the third is the optimization algorithm. Fourth is the output rate depend on the application. Since we are using the linear regression task, so regression task you have to use the linear activation, right? Linear activation means like this, okay? And loss function, which you have seen there was formula, right? Earlier, right? So always L comma Y hat, right? This is loss. So ideally this value should be 0, but practically close to 0, right? Now question is, who will make the loss 0, right? To minimize the loss or make to close to 0, we require optimizer, right? So optimizer, there are different type of gradient descent optimizer are there, but you understand that batch gradient descent, stochastic gradient descent, and mini batch gradient descent. Or Adam is advanced level, right? Forget about advanced. First you understand these 3 very basics, right? With 3 very basics, optimizer, you can build perceptron model for regression task, right? Okay. And output one node with the linear activation, so output will be using. So in a mathematical form, if you see that, put it here, let's use the sigmoid as activations, right? Inside using that, loss is MSC, mean square error. I hope everyone are familiar that, okay? 1 by m summation I goes to 1 to m y hat minus y square, right? And any one optimizer you can pick up, right, based on your understanding, but prefer will be later on this MBZD, because in your library that's called SGD, which is nothing the mini batch gradient descent, or Adam you can use, or other variants as well. So output layer always use the linear activation. Linear activation nothing, this part, right? So this is one as a loss, right? Ideally MSC should be 0, but practically the close to 0 here, right? Now then you can also build use perceptron model, simple talk of binary classification, right? Like as I told you, heart disease, right? Normal heart, ECG signal, and then abnormal, right? So if you want to do task right now, so you can do that. Likewise cancerous, non-cancerous, right? Or anything you can do like yes and no task, right? Like here best example, from your facial image you can predict that whether you are male and female, right? Give input as a facial image and predict that male and female, right? It's a binary classification task, right? So for the previous case here, this first and third, keep it freeze, any application, don't disturb. Keep on changing second and fourth depending on the applications, right? So in binary classification task, you need to use various binary classification loss function, right? And there are, lot more the functions are there, but you can use called binary cross entropy. So BC, that's called binary cross entropy, is most frequently used loss function as far as any binary classification task, okay? Also known as a logarithmic loss. And output layer you have to use the sigmoid activation function, right? This is I'm talking about, not perceptron model, as well as you can do even the multi-layer perceptron all. So this all the process will be remain same. So using the sigmoid activation loss, binary cross entropy minus k to c. So here k if you start from 1, right? So c should be 2. If you start from 0, then it should be 1, right? So here Tk log Fsk. Tk is your ground truth, right? Fsk is nothing the output of a model, neuron, which is nothing that your sigmoid activations, right? 1 by 1 plus e to the power minus sk. Minus sign indicates that always want to minimize the value, right? So loss, since we are using loss function, so always the objective will be to minimize the function value, right? But if you are looking at the broader context, cost function, you can maximize also. But in the deep learning field, we will be always using to minimize the loss function, right? I hope that makes sense here. Okay. Moving ahead, third class called multi-class classification task, right? Now, so in multi-class classification task, best example is, one such most popular example called handwritten digits. Whatever writing in the numbers 0 to 9 is nothing a multi-class classification task. In a medical field, what will you doing? When you go for the any oncology department, they will do the cancer grading, right? Now, like one is like binary cancer or non-cancer is a binary classification. Multi-class means grade 1, grade 2, grade 3, grade 4, right? What kind of cancer grade label is there? Whether liver, kidney, colon, or other kind, gastric and so on, right? So grading of a cancer is a multi-class classification task, right? You'll see some pictures, examples in my next class, right? So now loss would be used here called critical cross entropy, or we call as a soft max loss, okay? And output layer we will be using called soft max activations, right? All the things put in mathematical form, sigmoid activations, right? And this is a loss. Critical cross entropy minus I goes to C. C is a number of classes, right? More than 2 always. Ti log Fsi. Fsi is nothing the soft max activations, right? Which is nothing mathematically here, right? So you can solve a multi-class classification task as well using perceptron, even using multilayer perceptron as well, right? So if you see this function ESI divided by sum of j goes to c e to power s, right? So it give you the for all the classes, right? If you have 4 classes, it give you the probability for the 4 classes, right? Nothing else. But one more things we need to do called additional operations as far as practical is concerned. We need to use argmax functions, because softmax give you just probability for all classes. But you need to know, like doctor should know this is which kind of specific grade is there, cancer, right? To know a specific grade, you need to on top of use called argmax function, ARG. And then your output, which is called FSI. That's all, right? So it give you your specific class, right? What it does basically, let's say you have 10 classes, right? So FSI is giving the vector of 10 here, right? And here the nothing that will be probabilities here represented, right? So what argmax is doing here, it will see that column wise, right? For a specific sample, which particular class, here the column is having the highest probability, right? You start from 0 and let's say 9, right? 10 classes. So if this having, let's point, 5, 6, this is the highest probability, right? Compared to all, right? So what happened, this tell that, this argmax will tell that, okay, this the sample belongs to the 1 grade, right? This is 0, 1, I mean the 0 digit, this is 1, and so on like that. Right? So basically simple concept, always remember, it is scan the column wise and see that which column is having the highest probability. That will give you the class, okay? I'll demonstrate if possible in the laboratory session, right? Okay, so this is just perceptron model. You can be extended for multilayer perceptron. This is one example of multilayer perceptron, right? So here if you see, these are the blue nodes. So blue nodes represent the input features. Specifically, how many feature it accept model? Can you tell me? 3 nodes are there. That means the data should have how many feature? 3 feature only, right? So whatever the data is there, your data may have 10 features. You have to find out what are the 3 most prominent features. You have to just select 3 features and give as a column as a input here, right? And then the hidden layer 1, hidden layer 2, and then output layer, right? So one is called forward path, other is called backward path, right? So forward path is responsible for y hat computations, right? So if you want to compute y hat, give your y hat, right? So y hat is nothing, that output of a model, right? Neuron, MLP, right? And then we have called backward path. So backward path is responsible for network parameters. What are the network parameters? Weights and bias, right? In the previous case. So weights and bias are the parameters of the network, right? So the backward path, we will be updating the weights and bias. How will we updating? Wt plus 1 equal to Wt minus neta del loss by del W, where Bt plus 1 equal to Vt minus del loss by del B. Okay, gradient part, right? So those formula will be used for updating. But that what will happen, always it is the back propagation start, since it's back propagation name itself, that means start from the updating from this layer. So first the weight updation will happen this layer, then this layer, and then this layer, right? Okay, if you say that total 1, 2, 3, right? So as a vector, think as a vector form. W vector here 1, W vector 2, and W vector 3, right? So first will be updating by W3, and here the B3 bias, okay? And here then, here the B2 bias as a vector form, and then B1 bias, right? And here the W2 as a vector form, right? So here what the idea is, back propagations, the error get propagate back, right? So you need to use again the lot of math here in back propagation called chain rule, right? So using the chain rules, you have to propagate the error back, and you will be finally computing the W1 and reverse order always, okay? So if you zoom one particular node, you will be looks like this here, right? This is nothing your perceptron model, right? But AI is a black box in general because people don't know what is math. Input, give ANC and get output, right? But that's not the case, should not be the case for engineers or for developer. Developers should know each and every backend, right? How it was developed, okay? For example, if you want to know implement multi-layer perceptron or ANN, right? You should know all the math. You should know implement from the scratch, right? If you implemented everything from scratch, you have understood the algorithm, right? But ultimately you have to use library later on. But one type of scratch coding is must, right? So now, if you really want to understand all math, activation function and its derivative, okay, you have to do. Then loss function and derivative, you have to do. And optimization algorithm you should know deeper. And of course, this is output layer configuration. Need not to worry because this part you have understood there, right? So first three are very important, right? Now someone say that where activation function will be used in that, right? Derivative is important. So here del loss y comma y hat equal to del w, standard formula, everywhere applicable. So here if you see that, this is called, we are using a chain rule, right? Chain rule is the concept of linear algebra, okay? So this is the derivative of loss function, right? You can easily compute, right? And this part is nothing, the derivative of activation function, whatever you use at a output layer, okay? Yes or no? Right? Simple example. Let's assume that your loss is MSC, right? 1 by M. Okay? Sum of I goes 1 to N y I hat minus y square, right? Right? So if you want to build, right, ML here, so loss is this, and this part you can write y comma y hat, right? Since you want to compute the gradient with respect to the bits, directly you cannot do. So chain rule help you, right? So chain rule applying. Now first you can do very easily. This part you can compute. What will be the value? Del loss y comma y hat will be 1 by m, right? 2 by m, sum of I 1 to n y hat minus y, right? Okay? What about this? Loss is here MSC. That means you are going to solve a regression task, right? That means output node you are going to use Z, and Z equal to your Wx plus B, right? So what will happen here? And this is nothing your y hat for your information, right? Okay? So when you compute del y hat by del Z, right, this function become 1, right, for the linear regression task, right? What about this part? Del Z by del W, Z will get X, okay? So what is your formula will come finally if you want to compute? What the formula will coming finally? Will not get finally del loss y hat comma y del w equal to 1 by 2 by m sum of 1 to n yi hat minus y, right, into 1 into x, put a star as a vector form, right? And this value where you have to going to substitute w t plus 1 equal to w t minus theta del loss. Clear? You got this? You can substitute, you can write code, simple. You can implement that, okay? Likewise, you can do for the bias case also, right? That makes sense? So, you can do coding, you can understand, implement from this and get idea. Likewise, you can do lot more things, right? I'll just start the next step. Now coming to deep learning. So, deep learning, when I say deep learning, so deep learning requires, demand more data sets. This curve, if you see that when the amount of data increases, the performance of deep learning increases. Very simple, right? This is one example of deep neural networks which having the 8 input nodes, 4 output nodes, that means 4 classes, and 3 hidden layers. Each hidden layer is having the 9 nodes, right? This is called deep neural network. So deep neural network is nothing, it's an extension of artificial neural network, right? Yes.
So when you compute the backward propagation of the backward path, how do you determine the optimal value of the data?
Yes. The eta value between 0 to 1 as a concept, right? But practically you keep the smaller values, right? It may be 0.001, right? Or maybe 0.00001 or 0.0. So you have to always lower side, not upper side. So neta learning rate should be always keep it smaller, right? Fixed value, okay? And this also you'll get for a specific experiment. I mean that hit and trial methods right now. We're doing experimentations. What is the optimal rate? But there are various algorithms where, call optimizer, the learning rate keep on, reducing that, right? Give some learning rate and the learning rate will be updated, like that's called reduced learning rate, right? Plateau reduced learning rate you can use. So it will be reducing the after certain epochs. When the model is not improving, then change the learning rate. Then again, try to relearn it, right? And again, 10 epoch, it will checking that, okay? That algorithm is there to call adaptive learning rate, okay? But here, when you are coding from scratch, you have to implement from the, you have to for fixed values, fixed learning rate. But this is called adaptive learning rate also possible. I hope it's clear. So next, then moving ahead, like various architectures, like LeanNet and all. These are the architectures we choose for various classification tasks, right? This is one called LeanNet architectures. We'll be discussing more detail. This is called AlexNet architectures. One more thing, just want to give you as a concept here. What is the problem of this ANN? Major problem of the ANN is scalability. Scalability in the sense that ANN cannot accept the data as an image or video straightforward, right? Why? Because size problem, and if you take, it may take 10 days to do the task right now. So whatever the ANN model is there, you have, right? Models. Before that, we need to add called feature extractor module here. I'll say module, right? And then here you can give input as an image or video. Okay? So this feature extractor, this process, right, become automatic here. So that's called automatic feature extractor. So in a deep learning or in CNN basically, that's called one convolution operation, or let's say layer. Second is called your pooling. pooling operations. I am saying pooling because there will be some mathematical operations, right? These two are responsible for the feature extraction, right? Okay. So idea is that we need to make it as a end-to-end model, right? Give input data, get output, right? That's only important, right? So this is feature extractor, the models, right, or blocks. So convolution, set of convolutions, pooling, set of convolutions, and so on, and so on will be used that, right, for feature extraction, right? So this is the first model, right, as a AlexNet, LeNet 5. LeNet means here this model 5 stands for 5 layer total bits, right? And then input data, then convolution, then here average pooling, convolution, average pooling, and then you have called 3 dense layer. That's what it will be happening. Then AlexNet model, use that. I'll come back. Why do you use deep learning? Because of algorithm and advancement, powerful hardware, availability of large amount of training data, increasing accuracy and so on. And of course, have ability of learning unstructured data. Unstructured data means are those data for we do not have any ground truth. We do not have any labeled, right? Like your any like social media data, like your Instagram, Twitter, Facebook, right? Video recording, seminars, all things are the unstructured data. For that don't have ground truth. And the unstructured data basically is created by directly or indirectly by the human only, us only, right? And this data is increasing, day by day extensively, right? So when to use? Yes, you need to have a high computing machines, workstation, right? Number one, you should have a sufficient amount of data set. But if you do not have the knowledge of your traditional feature learning, need not to worry, because here the feature extraction will happen automatically, right? Where will be used? These are the major applications, right? As a one slide, I can give you 20 slides application, but in a broader aspect, signal processing, image, healthcare is the GIAN program focus, and then wireless communication, robotics, remote sensing, defense, data mining, and so on, right? So these are some core application in the your medical field, like pharma industry they have used, and lot of the application they building especially for respiratory disease, heart related things is most important, or most of the hospital use, doing the live monitoring of the BP, sugars, and all things. Doctor can see sitting at home by deploying the IoT sensor in the hospital as well. So all the applications which you have seen again could be 3 tasks, right? But before that, understand little more on the deeper part as the conclusions. As I shown you, it's a multi-layer neural network architectures. Why multi-layer? Because convolution layers plus activations, that's called one layer, then pooling layer, again convolution layer, pooling layer, then and so on. Then last will be a fully connected layers. This is the structure will be there. That's called multi-layer architecture, right? So this is one example. See input data, and then we have convolution, right? ReLU. This goes always together, right? Pooling, convolution, pooling, and then classifications. If you do classification, this will be used as a classifying task. If you're doing regression, this is called as a regression task, right? Now you will change. Output you have to change, that's all. This is other form of doing the as architectures, right? So let us understand that this architecture, this is what we see as a human, like 480, 480, 3 color image, but computer see numbers, right? As a number. I'll move on this. So any classical, I'll not go specific, just classical scene and talk about. So convolution operation, ReLU layer, that's 1A, 1B, then pooling, flatten, and then fully connected layers. This is standard way, and you need to understand math related to the convolution operations, right? And ReLU is nothing very simple, already understood. Pooling layer, just concept using, right? The rest everything is your NN part, right? So in a first layer, that's input data, whatever you have, make sure that the data should be have square image, in the sense that height and width should be same, right? It may be 32 cross 32, 28 cross 28, or 224 cross 24, right? That's what the prerequisite of the any standard CNN models, right? Then coming to the one you have image, other you have called kernel, right? Kernel, nothing is called filter here, right? So we are doing the as a convolution operations, 2D convolution operations, right? So blue is your kernel, right? And the green is your the input as a data, right? So see that 5 cross 5, kernel is 3 cross 3, right? Doing the operation here called convolve feature map, okay? So here you see that the size is reduced by factor of 2, right? For input was 5 cross 5 and output is a 3 cross 3. Why? Because we have not done any zero padding here in the input data, right? If you are looking at the output feature map, convolve feature map, same as input feature map, then you have to do call zero padding in the input data, right? This is a mathematical operations, right? If you want to know, G M comma N F M N input image. This is your two-dimensional kernel. This is what F K comma L H M minus K comma N minus K, right? As a mathematical operations, right? So here the kernel size, if you want to do the filtering, like what kind of zero padding you want to do. So padding amount always decide by H minus 1 divided by 2. What is H? H is a width of the kernel, right? Right? And minus 1 divided by 2. So if you want output is same as input, so what need to do? You need to do like this your input data. Right? Now what need to do? Since kernel size is 3 cross 3, so padding will be 3 minus 1 by 2 equal to 1, right? So we need to pad here 0 zeros, boundaries. Okay? After padding, what is the size will be? Please tell me. Before was 5 cross 5. After 0 padding, 7 cross 7. Right? Now size becomes 7 cross 7, right? Now again, if you want to do the same operation, what we do? You have to keep the center pixel here, right? Like this here. You can put here also will be there corners. Okay? So kernel like this here, right? This sliding like this. 3 cross 3 kernel, right? Just do the operations, multiplications, add it right here. Then one is tied, do that. Okay? Again do the same operations, right? Like this you keep on doing that. Keep on stride that. Here will be this. Like this here, right? So one is stride, keep on doing. Stride means just shift, nothing else, okay? So if you do this case, what is the size now? Convolve feature map will be same as input feature map. Okay? 5 by 5, right? So in the library you will see that when you implement valid padding and the same, right? Valid means there is no zero padding. Same means the feature map will be same as a input feature map, right? That will happen. I'll show you in my lab class right now. Now you can use a different type of kernels also, like could be as these are the nothing is detection map, right? Concept in image processing. Maybe the identity map kernel filters, edge filters, sharpen filters. You can also explore, right? But library as a deep learning library won't give you this. You have to do custom. You have to define kernel and just use that. You can use that as well for the different type of feature extraction, right? Why this kernel is important? Because kernel, the filters, right, will tell you what kind of feature you are going to extract right now. See, that's nothing that feature extraction. As I told you, the convolution role is what? To do the feature extraction, right? So that's why reason here we using the kernel, right, for doing the feature extraction. This example you can show that very clearly. We have input image, right, and doing the feature map. Nothing is element wise matrix multiplication will do that, nothing else, right? And this element wise matrix multiplication is nothing, it's a linear operations, right? So after that you have to do ReLU activations to introduce a non-linear, right? If using only convolutions without ReLU activations, that model won't learn, right? Now the learning won't happen, complex data won't understand. To extract the complex features, the data understanding, you have to introduce a non-linearity. So non-linearity that will be introduced by using the ReLU activation. Otherwise will be a simple multiplication, no. Matrix multiplication and addition is nothing, it's a linear operations, right? So this is a formula always keep in mind. W3, W1 minus W2 plus 2P divided by S plus 1. W1 is a bit of the input image. W2 is a bit of the kernel. P is the amount of padding used. S is tied, right? That give you the bit of the convolution map. Okay. Similarly, height S3 equal to H1 minus S2 plus 2P divided by S. Height of the input image. Height of the S2 is the height of the kernel. P is padding, same things, right? So you can do the height of that. Normally the size is W3 into S3 into SC. What is SC? SC is usually used for number of the filters used for doing a convolution operations, right? And this is, you understand, input data, and this kernel S2 W2, and here is D2. What is the D2 represent that? D2 is, you can say depth of the kernel, or let's say D2 is a number of such kernel use. If you are using 3x3 kernels, D2 such kernels use. And why this is necessary? If you are using D2 kernels, the network, right, convolution layer will be extracting D2 such features, such different features, right? Why different features will happen? Because there is a weight associated with the kernel when do operations. This weight initialization is a random weights, and that's called is, if you are using ReLU activations, it will be a he normal distributions, right? Distribution. So every time once you using kernel, so weights will be different, right? Weight will be different, feature will be different, right? So D2 such kernel case, we will get the D2 such number of slices or the feature map, and all are having different features, not a unique features. I mean the same features. This D2, this frames or the feature map, all we have the unique features. I hope that makes sense, right? Because this is a major confusion, guys who use the CNN and they don't know how it happened that actually, right? Confusion comes why using such number of filters. So normally in the feature extraction start from the low level feature to go to the high level features. Extraction will happen, right? Now time is there. We'll continue another 10 minutes. Yes, 5 o'clock will stop. Okay. So let's assume that I'll make it now logarithmic point of view. This input data, which is 4x4, this is kernel, okay, and do the convolution operations without zero padding, you get output this. Is that okay? Clear? Doing the operations you get that. Now I want to introduce the coding steps right here. So let's say create a convolution matrix, right? So convolution matrix we want to create from the kernel itself, right? So this is a kernel which is 3x3, and one more things keep in mind. Convolution is what kind of mapping? Many to one mapping. We have seen that 9 elements, right, is always mapping into one, right? One feature map, right? So many to one mapping will happen, right? Then this is kernel, right? So what we are going to do, we are going to get the convolution matrix from the kernel itself. So here logic is that first create a 0 of 1 into 16, right, as an array. So using np dot 0, 1, comma 16, this is a matrix created. Next step is replacing values by the kernel, right. It's very simple logic for I in the range of wk. Wk is here, the width of the kernel, right. So extend matrix bracket I comma I into h in colon I into h plus hk. H is what? Height of the input, right, equal to ki. Ki nothing here, the values of the row wise here, right. So when I equal to 0, what will the values? Here k equal to 0, right. So 0 into 4, 0, colon 0 into 4 plus hk is what? Kernel 3 cross 3. So 3 here, right. So 0 to 3 in this matrix is replaced by what? Ki. Ki means k0 means 141, right. So see here 141, 0 to 3, right. Now it goes to 0 to 3 means 0, 1 and 2, right, indexing. So 1 and 4 are replaced. Then I equal to 1, what will happen? 1 into 4, 4, colon 4 plus 3, 7. That means start from the 4th position to 7th, right, 4th, 5th and 6th, right. So 0, 1, 2, 3, 4, right. So this is 1. So 1, 4, 1, replace 1, 4, 1, right, 3 values, okay. Then next is I equal to 2, right, I equal to 2, because we have what? Wk is 3, right. So 0, 1, 2 range of Python indexing. So when I equal to 2, what will happen? 2 into 4, 8, colon 8 plus 3, 11, 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 to 11, 8, 9, 10, right. So 3, 3, 1 replace here. This has got your matrix. Clear? Create the row matrix. Now from the row matrix we need to create a 4 into 16 matrix. Why? We are creating reverse logic. You have the need to get the data, and this case we have input is what? 4 into 4 means that will be a 16 into 1. 16 rows, 1 column, right? And output we have 2 cross 2. That means 4 into 1, right? Output is known. Input matrix is there. What is the matrix size? Conversion matrix will be 4 into 16, right? 4 into 16, if this is there, then only we'll get this. Correct? No? Right? That's what we are creating. So first you need to know what is input data, right? What output you get, feature map by using the formula W3 equal to and S3 formula use get the size of output, right? And then you determine the size of conversion matrix. Very easy, right? You can do that. What is the size? You can compute that. So from here, so extend kernel, we want to extend that. Empty matrix, 2 for loop for I in the range of WO and J in the range of WHO. WO equal to 2, HO equal to 2, right? And extend matrix 1 equal to np dot roll extend matrix comma H into I into S into plus J into S, right? So what we are going to do? S is a slide which is fixed, right? So I equal to 0, 4 cases. I equal to 0, J equal to 0, right? What will be this? There will be no roll, right? So this matrix same as the input only. This first will be remain same. Clear? Extend matrix. Extend matrix is nothing that already we had previous. Because H4 into 0 into 1, J0 into S1. So basically no roll, right? This is a Python role, NP role, right? Concept is there right now. That's why I told Python fundamental is important right now. Okay. Now I equal to 0, case 2, J equal to 1. What will happen? I equal to 0, So this fellow is 0, J equal to 1, and here S equal to 1. That means what happened? In this matrix, roll by one sample, right? So the last fellow will come and sit into front. Okay? Last fellow will come and sit into the front, right? That's called NP roll, right? Second, third case, I equal to 1 and J equal to 0. When I equal to 1 and J equal to 0, right? This what happened here? 4 into 1 and this 0. That means 4 sample will come and sit in the front. Reverse order from here. This 4 sample you see. Right? Fourth condition. I equal to 1 and J equal to 1. That means 5 samples. 4 plus 1, 5, right? So start from this. 1, 2, 3, 4, 5. Right? Come and sit right. This is called NP roll. So this is a matrix created, right? Convolution matrix. And then next step is convert your input data, input image into a column vectors by using flatten operations. Input into flatten it here. Then this convolution matrix, right? Multiply with your convolution, this column vectors, right? Flatten input data. You get your feature map, convolve feature map. And then after that you just do reshaping. Reshape command is very important in Python, right? Reshape it, you get this output, right? Why I told you this logic, this concept, Python coding, how you implement it? Because lot more applications in the deep learning, which called segmentation model, like UNet and so on, you'll be doing called upsampling, right? In upsampling, what we'll do? Whatever the convolution you have created, just do the transpose of this, multiply with the flatten of the convolve features, you get the upsamples data. So if you know this part and designing the any segmentation model, they are doing upsampling. That's called transpose 2D convolutions. That's very simple, right? So before you have seen that only convolution operations. Now use the ReLU activation. So this is without using ReLU activation. This is after using ReLU activation, which is map, right? I hope that clear for you guys. Okay, the concept of convolution actually, right? How it works basically. And then use the ReLU activation to reduce the nonlinearity. So this will be feature map after rectified linear unit. Then do the pooling. So pooling operations, there are 2 types. That's called max pooling and average poolings. Again, this is what it does. In max pooling, the kernel size will be 2 cross 2, right? So 2 cross 2 and stride will be 2. Previous case stride you have seen 1, right? So 2 cross 2, first taking the maximum pixels, maximum feature value. So first, if you see the matrix here, 2 cross 2 window, what the maximum feature value is 100, right? So pick it 100, then stride 2. Pick the maximum feature, so 184, then stride down, 45 here this window, then again stride 2, you will see that here all are same to get 12 here, that's called max pooling, right? Max pooling means we are picking up, right, the most important feature of the convolution layers output, that's all, okay? And then in average pooling, what we'll do? Same concept, but instead of taking the maximum, what we'll do? Add all 4 samples, divide by 4. Take it the average, right? Add all, divide by 4. Add all stride 2, divide by 4. Like this you do that. Right? If somewhere is coming fractional, fine, you make it round off that. Okay? That's called average poolings. So these poolings, basically max pooling and average poolings, are also feature extraction layer, right? As I told you, 2 layers, right? Convolution layers and max pooling layers are responsible for automatic feature extraction. That makes sense? Okay? So this is visualization, like from rectified input given to the max pooling, looks like here, right? And this pooling layer is required because of to reduce the number of parameters of the input tensor, and thus help in reducing the overfitting problem, and also reduces the computational complexity and improve the adds in the efficiency. Extract representative feature from the input sensor, in the sense that extract most important features from the convolution layers, right? Then next step, flatten, because whatever the feature you are getting, the convolutions and the max pooling, always the feature is a two-dimensional, right? Now, but last, as I look at the classification or the regression, that ANN always accept data in the column vector, right? Column format, column vector data only. So you have to convert two-dimensional data into a one-dimensional data in column vector form. So for that you can use, that's called flattening. Very simple. First row, put it here. Next row, put it here. Very simple. In that's called, Python called flattening operations, right? You have to convert into a column vector, because next is your fully connected layers. Fully connected layer is nothing, your ANN model, what you have learned earlier, right? So it will be your nothing, your GWX plus B. So for fully connected layers, your input should be in a column vectors, right? Last layer will be your final layer of the CNN model, either the classification task or the regression task. If the classification, either using the sigmoid or the softmax. If regression task, you have to use the linear activations. Okay, that makes sense? Now, and this is a softmax, right? And softmax, you know, all the like the sigmoid function also, if you are using output lower, that give the probability for the classes, right? Probability only, right? Softmax also give you the probability for classes. If you sum all the probabilities, you will end up with 1, right? Same thing, if you have 2 class, add the probability for 0 and 1, you will get the 1, right? Okay? But both the cases we need to do additional operations. If you are using binary classification, if you know what exactly class, you have to do thresholding, right? Greater than 0.5 belongs to class 1, less than or equal to 0.5 belongs to 0, right? There also we need to do that, additional operations to get a specific class 0 or 1, right? So this is a derivative part, right? This derivative is not very straightforward, right? To get the derivative, you know, again, linear algebra, right? That will help you too. So this is one illustration of the softmax input data, these features, and if you see that softmax giving the 0.46, 0.34 and 0.2, and you can get the, you know, sum of all, it will be 1. And y1 you can calculate ex1 divided by sum of all, ex1 divided x1 plus px2 plus ex3, right? Put all the values, get likewise y2 and y3, you can get that. These are nothing, these are probabilities y1, y2, y3. You can do that part. Now, so look at this part now. I hope that's clear. Input image, convolution plus ReLU, then pooling, convolution plus ReLU, pooling, fully connected layers, and output, right? 4 classes, dog, cat, boat, 0 and 1 like this, right? That makes sense, right? By using convolution layers, right? Pooling layers and so on for feature extraction, right? So you can see it's little bit visualization of train the model here, layer wise how it looks, right? As different layer, input layer, convolution layer 1, pooling layer output, then 2, 3 and so on. Output how you get the feature map. This part you can see layer 1, layer 2, layer 3. You can see that here the feature extracted layer 3 is much better, right? So in the initial layer, we will be extracting the low level features, right? You move deeper, we will be extracting the more the features of the model. I mean that models give you the better features, high level features will be extracted that, okay? So these are the 3 basic models, right? I will not talk that, like AlexNet. Now you can understand this model very clearly. Look at the model now, right? Input data, convolution, pooling, here average pooling, you can do that. You can calculate the size, shape, how it is calculated, will not have a problem. Okay? That makes sense? So, this data set is very important, the model which was introduced by Lee Kuhn et al. So 5, as I told you, 5 baited layer. Bait means baited will be always associated with the either convolution layers or either the fully connected layers. So bait will be here, this layer, this layer, this layer, this layer and this layer. That's called 5 baited layers. Okay? So you can calculate the bait at each layer, right? Each layers. If you have dense layer, formula always. Again, very important, you will keep in mind. So if we have fully connected layers, which we call normally a dense layer, right? So the bait will be parameters basically, right? Input, whatever the feature is there, input feature multiply with the number of node, right, plus the number of node. This is for the fully connected layer, or the basically ANN, you understand, simple ANN part. Input features, right, multiply the number of node, right, for example here, right, okay, and this is a fully connected layers. So let's say you have this column vector which is coming, let's say 184, right, input, and this node, let's have a 84 nodes, points, 84, right, and here the bias also will be there, here the bias also will be there, right. So what happened, this goes to input to the fully connected layer, right. So the number of the parameters will be 784 plus multiply 84 plus 84. So this will be the parameters at this particular layer. Okay. Similarly, next layer also, right, you see that for the here the input 84 nodes will connected to, let's say you have next layer, you have, let's say we have 50 nodes only, right. So 84 into 50 plus 50. So the number of parameter will be at this particular layer. Okay. Now output layer is softmax. Here 10 label written, for example, right. So 10 into 50 plus 10. So that will be baits at output layer, final layers. Is that clear? Make sense? This is about the ENN related or stuff, calculating the parameter with the pen and papers. If we have the CNN layer, convolution layers, right? So parameter will be input feature F into F into depth into F, number of the filter, plus number of the filter. D means here the depth, right? For this case, if we have 784, so we will use D as a 784. What is F is a kernel, 3 cross 3 or 5 cross 5, whatever you use, right? Number of the filters. So for example, if you see that here, right? So this case, they use 6 number of filter doing the conversion operations, right? So that's why you are getting 28 into 28 into 6, right? So 6 is a filter, right? And then your size will be number of the parameters, very important. F into F plus into D into number of filter plus number of filter, right? So you can calculate every layers, write the convolutional layers, how the parameters coming there with your pen and paper analysis. Okay. That's all. Rest everything will continue there. Pooling layer does not contain any parameters. Keep in mind that. Parameter only convolution layers and then your dense layer or the fully connected layers. Okay. That's all. Now.
A question about the basic diagram we showed about the ANN. You seem to emphasize, if I understood right, the role of bias. Is the bias as important or more important than the weights? I thought the weights were more important.
No.
But you emphasize bias.
Bates, basically while the learning, bias is used just updating the output of a neuron. Okay. Bates give the power to, get the optimal values. That's y hat. So y hat value when Bates are optimal, where the Bates as well bias when become optimal, then y hat will be y equal to, right? So that means the estimated output is equal to close to your targets. So both are playing the significant role. So right, Bates as well bias are equally important, right? But in MLP, your bias value could be 0, but the Bates should not be 0. It should be always random values, because when Bates becomes 0, right, then there will no learning will happen. Updation won't happen, right now, because I did not go for the back propagation more detail, just very basic concept I told you, right? But again, to understand back propagation, you need to go for more on that part. Roughly 30 to 40 minutes required to make understandable that part. Okay. So we'll continue, take it forward for as a practical applications for the for histopathology domain as well. Any questions we can take? Okay, you can note down, tomorrow we can have also.
There are no questions. I thank Professor Shyam for this wonderful lecture. And tomorrow again at
Yes.
3:30.
I'll continue.
So we'll again meet him tomorrow.
So tomorrow I will also introduce something called optimizer, right? And little bit I'll give you the one loss already you have seen. Not possible to cover all the things, right? But at least you get some idea, right? Implementation part, right? See.